Hello everybody and welcome back. Okay, let's begin. Nice and simple. We're gonna launch Leadwerks engine. When Leadwerks engine fires up, we're gonna create a new project. Okay, Leadwerks engines usually defaults to opening up the level editor, so we're gonna go to File, Project Manager, New. Okay, so this is Leadwerks, easy peasy lemon squeezy. Fantastic. It's gonna be a blank project. Open up. Okay, and if you're going to press OK, that's going to open up the Leadwerks level editor for that project. But what we want to do is go back to the project manager. We want to double click on this project. That's going to open up the project folder with all its dependencies and source files and, all the contents of your game stored in here. Fantastic. So how do we start programming in C++? Go to Projects, Windows, and there's our Visual Studio Solution SLN file. We're going to run that project. Okay, Visual Studio will start scanning the project folder for a moment to assemble all of the dependency files. So as you can see, it's happening down here. All the header files, anything and everything related to the engine is being scanned so that you can actually use it in this project. You'd be surprised at just how simple it is to actually get this project up and running. Okay, ready, fantastic. On the right side, we go to the project name, sources, main C++. So the main C++ file is where your application goes. You already have a bunch of stuff in here, and I cannot stress enough how important it is that you do not touch any of this code. If you touch any of this code, if you accidentally delete something or type something in here, you will break the engine and it will be a nightmare trying to figure out what is happening and how to fix it. So for that reason, we're going to select it and delete it because we don't want to bother with that stuff, to be honest. That's way too risky for us. We're going to start with a blank project. And okay, blank project. So what do we do now? We need to first of all import the Leadwerks library. So include, #include, leadwerks.h. Leadwerks.h is the header file that contains all of the Leadwerks references and all of the features, functions, classes, anything and everything that Leadwerks offers as a game engine is stored in this header file. So we're basically load up the Leadwerks engine library. Next, every application needs a main function. So how do we create the main function? Well, we're gonna do boolean main, open up the round brackets and open up the curly brackets. Whatever's in the curly brackets is your game code, loading up maps, movement code, cameras, creating, deleting, shooting, yada yada yada. Anything and everything about your game goes into the main file. Okay, now if I'm gonna run this right now, you will see that the debug window will open up and then you'll see a flash on the screen very briefly. So pay attention, very briefly. Okay, and okay, so you see, oh, there we go. So you see the debug window. That's fine. Application is running. Everything is okay. Now, right now, the application is basically just an empty function. So what happens is it enters the function, it goes to the very end, it exits, and that's it. End of application. Application closes itself. Everything's fine. That's how it's supposed to be acting as of right now. Fantastic. So, in order to create our game environment, we need three things. We need a window, we need the context, and we need the world. So the window is the physical game application window. The context is basically a canvas inside of which we can then create the 3D world and do lights, cameras, action, yada yada yada. So how do we go about creating the window? Now, creation of the window is a Leadwerks specific function. So Leadwerks engine offers a set of features and functions specifically made for creating that application window. So how do we do that? Well, we got to go Leadwerks library. From Leadwerks library, we're going to pull up a window class. Window class is the class specifically created for creating, deleting, changing the values and parameters of windows. Okay, with the window class, we need to create a variable specifically made for specifically catered to be able to store the window. We don't just want to create the window. If we want to change that window later on down the line, like change the resolution, maybe some parameters, vsync, we want to make sure that when we create the window, we save that window into a variable. And then whenever we want to change the window, we just use that variable to address those changes. Okay, so we're going to make, let's call it my game window. This, you can type anything in here. This is just a variable name. It can be anything. So we're going to say equals, and once again from Leadwerks library, we're going to pull up the window class once again, and this time around we're going to run the create function from that class, and the create function actually creates the window itself. Now get this, in the create function, you can supply parameters like the width and height of the function. As you can see, the suggestions just pulled it up for me. The title of the window, the title of the application, the width and height, the position, yada yada yada. Now, how do you know? How do I know this stuff? When you're searching for these things, how do you know what these functions offer? Well, you know, you can always move your mouse over it, but sometimes, what's another way? Well, it's fairly easy. You can actually open up You can open up the Leadwerks documentation, and this is the documentation. All you want to do is go to API references. This is your C++ reference point. You can also go to index, which will list all of the engine's functions for creating your game. So if you're searching for something like create, it'll actually give you the search results for various create functions. As you can see, we have a bunch of create functions here. There's create for entities and models. There's create for lens flares. There's create for directional lights. There's create for clients. And if you take a look at some of these, you can see that they give you parameters, right? So parent. What is parent? Parent is you want to attach this entity to something when you create it, put in a parent, right? So in my case, I'm looking for, let's see, I'm looking for the window. So if I go to the API references, window, there's the create for the window, and there's the list of all excuse me, there's the list of all the parameters that we can supply into it. And as you can see, there's also the same definition here. Okay, title, X and Y position of the window, width, height, and style. So we're going to cover, well, let's do the first 5. And you don't have to put in all of these together. You don't have to put them all at the same time. You can just put the first 3 or the first 5 in this case. Okay, so we're going to go ahead and go back to Visual Studio. First of all, the name of the window. Easy peasy game. Gamaya, apparently. Game. Okay, the position in which we're going to create the Leadwerks window is going to be 0, 0, which is the top left corner of the screen. The width is going to be 1280 by 720 because we're not heathens. This is 2019. And that's it. For the time being, that would be more than enough. You can omit the rest of the parameters. That's fine. So what's the next thing that we need to actually generate? The next thing we need to generate is the context. As I said, the window is just the box. You need the context, which is the canvas on top of which your game content is actually being developed in. So same thing, from the Leadwerks library, we're going to pull up the context class. With using the context class, we're going to create a variable that's going to be responsible for storing the context that we're going to be creating. So that's going to be my context. Once again, this just a variable name. You can call it armpits, right? You can call it anything you want. Okay, and now that we've created the variable, we're going to go and once again, Leadwerks. From the Leadwerks library, we're going to once again use the context class, and now we're going to run that create function again. So, I mean, if we're going to go to, let's say, back here into context, we have, you see, these are all the context related functions. Draw line, draw image, draw text, draw rectangle. This is like graphical user interface stuff, basically. You have set shader, set blend mode. We want the create function. And what do we have here? We have the window. So the window to create the context on, okay, and as you can recall, this is the window that we created, so that's what's going to go inside of here, right? And there was a second parameter. We're not going to touch it for now. We can just leave it as it is. Last thing, now that we have the context, which is our canvas on which the game is going to be created, all we need to do is create the world. The world is where the engine, the three-dimensional space of the engine actually takes place. Once again, Leadwerks, from Leadwerks library, we're going to pull up the world class. Using it, we're going to once again create the variable that's catered towards storing that world, right? It can't be an integer, can't be a string, can't be a boolean. Has to be a variable that's created after the same class that creates our world. And once again, Leadwerks. If I didn't make that clear, you know, the first 5 times. Leadwerks, we're gonna once again pull up the world class, and we're going to use the create function from that class, and well, that's it. So this should create our window. Within that window, we're gonna create the context, and now we create the world that's gonna be rendered to the context. Right? We don't have to put the context here. That's it. We're done. Okay. So if we're gonna run the application right now, you will see a debug window, and you will see a brief flash. Oh, you saw it, right? You saw the big window pop up right at the top left corner. Now, what's happening here? Well, what's happening here is that, take a look at the logic of the code. We load up the library, we enter the main loop, we create the window, the context, the world, and then the code reaches the end, and that's the end of the application. So the application automatically closes itself. How do we keep the application open so that we can, you know, not have the game that lasts for a split second? Well, all you have to do is do while from lower case, and while true, and putting a curly bracket. So you've just created a loop. What's going to happen now is that it enters the main application, the main function, window, context, world, then it enters the main loop, and this thing is going to loop over and over and over and over and over again until you yourself make it exit the loop, which is, you know, probably the point when the user clicks on the exit button in the game. Okay, so if we're going to run this now, you will see that our window actually stays. So there we go. There's our window. Fantastic. So we're going to go ahead and, you know, hunt for that close button. Okay, so fantastic. We have our application window. What's next? Well, in order to make Leadwerks engine work, Leadwerks engine needs to update itself on its physics, on its lighting, rendering, the time. So all of these things, you know, in order for things to keep moving forward, you need to first of all update the time. So we're going to go ahead and type in Leadwerks time update. Okay, now here's the main thing. You notice that we have to type in the Leadwerks library keyword whenever we want to use Leadwerks specific functions. This is going to get old and tedious and cumbersome very quickly. So we can tell Visual Studio that all these functions, the create window function, create context function, you know, the create world function, we can tell Visual Studio that it's going to be coming from the Leadwerks library by default for all of these functions. So in order for us to do that, we can use we can put in using namespace Leadwerks. So this basically says that this will automatically come from the Leadwerks library. And now we can go ahead and just remove all of the mentions of the Leadwerks library, and suddenly you will start seeing that the code is becoming much less tedious and cumbersome and a lot more friendly looking. Okay, fantastic. So let's go back here. We update the time. The next thing we need to do is update the world, right? Now remember that I call it, I call it world. So if I called it my game world, then obviously my game world is the one that's going to be updated. So take a look at this. When you create the new world, the new world is being stored in this variable. The variable is created from the template of the class world. So this now contains our game world. And if you want to edit anything in that world, you basically go world minus and closing angle bracket. This is an accessor. And then you run from within this world the update function. These functions already exist within the world that you've created. And this is what the engine does. It already has all of these things handled for you. You just run the functions that do the things you need to do. Now, how do you know which functions this world would have? Easy. We go to documentation. We go to API references, world. Okay, and here's all the set of world functions. So we have world update. I believe that's it. Yep, update. Okay, so if you want to do anything to the world, you can get the gravity of the world, get the current, which I have not yet experimented with. Set the gravity, set the light quality, physics detail, which is how precise the physics calculations are. Water color, water height, water mode. As you can see, the water function is built into Leadwerks, so you can set your water level. Once again, one of those things you don't have to code yourself. And yeah, these are build nav mesh. This is really useful. This is for building the navigation mesh for artificial intelligence to run around, so you don't have to do it yourself. Another benefit of using Leadwerks. So yeah, these are all the functions for the world. If you want to change anything about the world, this is what you do. Okay, fantastic. So go back to the solution. We update the world, which updates all of the physics and whatnot. Next thing we need to do is we need to render the world. And once again, if I change my game world name to that, then I need to update that world. All right. After we render, we need to now update or synchronize the context. So we say context sync, and in here you have an option of putting true or false. And this little feature is basically the vsync or the virtual sync. If you want to prevent tearing on your screen, if you have a monitor that supports vsync, you can enable vsync here. Alternatively, you can make a little user menu in the properties of your game where they can toggle vsync on or off. So for example, you can make a Boolean variable called toggle vsync, and it will be false. And you can basically shove this variable in here, and all the players can just change this to true in the menu, like you program a button that changes this to true, and suddenly they have vsync for their game. Okay, simple as that. So for the simplicity of it, let's keep it in here. Fantastic. So we update the time, which updates the physics and everything. We update the world, we render the world, and then we push the render to the context, which is in Windows, so we can actually see what's happening. If we're going to run the project, once again, we're not going to see anything because we actually haven't loaded up any environments on any content for our game. Okay, fantastic. Now let's go back in here. Let's hunt for that close button. Okay, so here's the thing. I don't want to be hunting for that close button every single time I want to close the game. I want to press escape, and that will close the game for the time being. And later down the line, I can change escape to a menu, and then they have to press the button in the menu. Okay, so how do we do this? Well, guess what? You have the window, right? You created the window. What sort of functions does the window offer? Okay, we're going to go back to API reference, window, click on window, and okay, so we have flush keys, get current, key hit. Hey, look at that. Key down, key hit. So function that gets the key hit state of a window. The key to check. So it looks like this function is responsible for detecting whether or not a key has been hit. You also have a function called key down, which checks whether or not the key is being held down. Key hit is a singular action, just press. Key down checks whether or not it's being held down. For as long as it's held down, it's going to basically return true or false. Okay, so we want key hit. How do we go about actually using it? We're going to go in here, and let's plug in basic if statement. So if, round brackets, curly brackets. How does this work? If whatever's in the round brackets is true, we're going to execute whatever's in the curly brackets. So in here, we're going to need to do if my game window, whoops, So this window right here that we created, if my game window, this would be key hit, and then we're going to open up the key hit. In here, we need to supply the key that we want to use that we want to detect. Now, how do we do that? Well, once again, you can just go to the documentation, go to search, key hit, click on that, key hit. Okay, so this gives us, yeah, look at that, key space. Okay, well, I mean, that's pretty straightforward, if you ask me. Shove that in there. Instead of space, we're going to type in escape. Okay, and here's the thing. In order to close the game, all you have to do is return false. So what's happening here? The while loop will continue being on a loop for as long as it's true. We return false, this changes to false, we exit the loop, the game closes. Okay, nothing complicated. And hey, look at that, you've already learned how to take keyboard input. So, I mean, half of the game is pretty much right there. Okay, press escape, game closes. Fantastic, nothing difficult. Okay, so let's get into the meat and potatoes. Let's load up a level. Let's load up a game world. So this is where I love Leadwerks engine. It makes this so much easier. First of all, it offers a level editor, which is something that can be said for a lot of engines of the same caliber. We're going to open up the project. We're actually going to open up correctly by pressing OK. Fantastic. So we already have a single light. I believe this is a directional light or sunlight. We're going to create a plane. All right, we're going to drop it down. Let's drop it down like right on the floor level. Okay, we're going to create another plane right up here. And the reason being is because I want the sunlight to actually affect it. Okay, fantastic. All right, now something that you might want to watch out for. Sometimes you may be creating objects and the objects don't actually have a that doesn't have a color on it, right? And the reason being is because if you ever have an object that you create that doesn't have a color on it, or let's say this little grid texture, you can actually go right here into assets, materials, developer, and you can drag and drop this material into any one of your objects, and it's going to apply that material to that object. Oh, that looks interesting. Fascinating. Yeah, and you can just go ahead and apply that material to your object so you can actually see what it is that it's doing. Okay, I'm going to move this guy a little bit over here. Okay, I think that's good enough. So, fantastic. We have our map to experiment with. I want to get this map and I want to load it up into the engine using C++. Okay, first of all, we need to go ahead and save this map. So, where does the Leadwerks save the maps? Okay, we're going to call this test mappy map save. If we're going to go to the Leadwerks project now, if we're going to go to maps, testy mappy map. Fantastic. Now, inside of Leadwerks, inside of Visual Studio, I mean, there's a function for loading up maps. The function is called map load. Okay. And we're going to open up the round brackets and the quotation marks. Don't forget the semicolon at the end. Now, the path to the map is relative to the path of the project. So if we're going to go, this is the project, how do you get to the maps? You have to go to folder map, and there's our map. So same exact thing we need to say. We go to the folder maps, and then we get our map. Okay? So that's it. That's how you load maps. You run the project. You will most likely not see anything though. The reason being is we do have the map in there, but we don't have a camera. We need to create a camera. Okay, fantastic. So we need to create our camera. In order to create the camera, we once again have to use the camera class. We create a my PL cam. This can be anything, as I said, my player cam. And now we once again use the camera class, and we're gonna create the camera itself, and that's it. For the time being, we can just do this. Let's run the project. And Okay, fantastic. So we can see some stuff, but you see we actually spawned the camera smack in the middle of our ground plane. So we need to move the camera up above. Okay, there's a escape button, or I can press escape and actually do that. As you saw, I was pressing the X button and the X button wasn't actually doing anything. So we actually have to program in that when you press the X button, it closes the game. So we have the camera. We need to move the camera. How do you move the camera? How do you move anything in the game? Well, you can do, let's say, my player camera, and we're going to use the accessor, set position. We're going to set the position, so 0, X, so left and right, Y, this would be, let's do 5, and Z, forward and backward. So 3 values, left and right, up and down, forward and backward. If we're going to run the project, okay, there we go. We'll lift it up the camera just a touch. I think it's still, however, clipping through the through our game world, or our camera is just being positioned somewhere else. So what I'm going to take here is make this a lot bigger. I'm going to make this a lot bigger. Okay. If I could just... ooh, come on. Did I find a bug? Okay. There we go. Okay. Might have been a bug. Okay. We have our ground plane. Fantastic. We're going to save. All right. And now we can go in here. We're going to run the application by pressing F5. And there's our ground plane. Fantastic. We have the camera. What I want to do is actually want to move the camera backwards just by a bit. Let's move it by maybe 10. We're going to make a little bit of space, and we're going to create our player object, the like third person or first person player object, whatever you want to do. Actually, we just move the camera forward. We're going to do -10 in order to move it backward. All right. Building. There we go. So we'll move the camera backward. Let's create a player object. So the camera doesn't have any sort of physics attached to it. The camera just renders whatever it sees. We need to create a player object and then attach the camera to that object. And when we move the player object, the camera moves with it. Okay? So we need to create, what we need to do is we need to create a model. All right? So let's do model. We're going to create... Let's see, we need like a box. So we're going to create a variable called player box using the model class. And this will be equals to model, model, create. And we're going to do, actually not even create, we're going to use a box. Yes, so this is how you create a box. There is a function called create, and we're going to cover it in just a moment. Create creates an empty model, not a box, not a sphere, not a cone, just a point, empty model, and it's an invisible point. It's just a virtual space point, and it's invisible. You can attach stuff to it, and it can have physics to attach to it. So if you could create a box in this case. So if we're gonna run the project right now, we should be able to see a box. If we don't see a box, chances are it's stuck in the middle of the level. Oh, there it is. It's halfway in the level. So once again, we want to move it up. So we're going to do player underscore box. Excuse my typing. This is why I hate doing typing tutorials. It's just so much time wasted typing. Set position. Oh, for God's sakes. Position. We're going to do... So XY, we want to move it up by, let's do by 5, 4, whatever, 3, 2, 1. So we're going to move the box up. Very simple. Okay, we move the box up. Fantastic. So now we need to, that box is just a box. It doesn't have any physics attached to it. It's just geometry mesh. Nothing else is getting calculated for it. We need to enable, since that's going to be our player box, we need to enable the physics system for that box in order to control it and in order to have that box interact with the rest of the environment. So here's what we do. We do player set, excuse the airplane raids. We're gonna do set physics mode. Okay, now if you take a look at this function, set physics mode, all right, we have a choice of two types of physics mode. We have rigid body physics, which is, you know, barrels, items that can be moved in the game, maybe things on hinges like doors that can be like kicked open and maybe shot and the bullets actually move the door. Anything that's like a physics object that can be moved in the level. Maybe an explosion happens and a bunch of stuff flies all over the level. That all other stuff will be a physics object. Or the character physics. The character physics is for your NPCs, for your enemies, for your player, the main character player. Anything that's a little bit more complex than just a simple shape that's supposed to be succumbing to the physics. So that's what this particular thing is. We're going to copy this. That's what the particular box is going to be. We're going to shove that in there. Don't forget the semicolon. And here's an important thing. If you're enabling physics, you need to set the mass of the object. If you don't set the mass, it will assume that the mass is 0. And when you set the mass is 0, the physics don't apply to the object, right? So you need to do player box. And this is something that made me pull my hair out because I couldn't figure out, I'm setting the physics mode. Why isn't it working? And I had to figure out why it wasn't working. So we're going to do player box. We're going to do set mass. You see we have get mass and set mass. We're going to set the mass to 1 for the time being. Okay. So if we're going to do this and run the project, this will either work or make me look like an ass. There we go. Okay, fantastic. Our box is now engaged with the physics. But here's the thing. You will notice that the box has just fallen through the ground. Why did the box just fall through the ground? Let's make the box a little bit bigger, shall we? So, could have pressed escape. Okay, when we create the box, you can leave it empty, which will create an empty box, or you can do the following. Let's see, where's our box? There we go. Box, shape, and box model. Yeah, there's two different boxes you can create. You can create a shape or the model. The shape is for defining the shape of the physics solution. Like you can have a super complex model with like ridges and little rivets and stuff that's sticking out of it, but the collision that's going to be calculating is just the basic cube, right? That's what the shapes are for. Okay, we have our model, and as you can see, we can set the width, and the width, when you set the width, it basically scales the height and the depth respectively to the width, and it's all uniform. Or you can set each individual parameter separately. You can also set the parent, which is important. When you create this box, you can say that this box will be parented to another entity, another box, another shape, another model, and whenever that model moves, this box will move as well. Very important. Okay, so we're gonna say, yeah, we're just gonna use a width. So if we go over here and say box of 2, box of 2. Okay, do you see how the box sinks through half of the floor? Now this is absolutely normal behavior, and I'll show you this in just a moment. If we change this to a rigid body physics. Oh, come on. I keep pressing the rigid body physics. Okay. If we do that, set the mass to 1, and that just falls through the floor. The reason being is because we actually have to set the interaction of the physics to actually interact with the world. For the time being, we're not going to cover this. The rigid body physics has to interact with the world, and you have to enable that. But here's the problem, or here's the reason why the character physics is falling through the It's falling through the floor. I was expecting the rigid body to just fall on the ground correctly, but apparently that's not the case. And if I'm gonna start exploring it right now, it's just gonna be like a much longer video. So I'm just gonna can that subject for the time being. We're gonna explore this right now. So it's falling through the middle because when you set the collision type to character physics, the character physics mode has its own collision mesh that it uses to calculate collisions. Now, how do we know what that collision mesh is? We can use a function. We can use a function on our camera in order for the camera to see our collision meshes and our like debugging for the collision stuff. For the collision mechanic and the physics mechanic, we need to make the camera be able to see those things. That's why we're going to use my player cam. We're going to set debug physics mode, and you can set debug for the navigation mode, which is the nav mesh or the entity boxes, etc., etc. You can debug a lot of different stuff here. So we do debug physics mode, and we're going to set it to true. What's going to happen here is that the camera will now be able to see physics, the physics shapes. As you can see, there's all the outlines for the physics shapes that calculates our physics interaction. Take a look at the player the player controller collision mesh. Basically, it has a cylinder, and this cylinder is responsible for calculating collisions of the player with this entity. So this is where it's a good idea to switch how you're gonna handle your. Let's say we're making a third-person character, right? This is a good idea to switch how you're actually going to handle the construction of that, for that character that you as a player are going to be controlling, or maybe that's an NPC. Instead of creating or importing the model of your character and setting the physics mode of that model, instead we're going to create a dummy model, the dummy point. Do you remember when I said the instead of box you can use create? That create creates an empty point, and that empty point can have its physics mode set to character physics. So if we go ahead and let's do the following. Let's comment this out for the time being. Can we? Oh yeah, Visual Studio Control CK. Oh, Control apparently. Okay, or KC. Yes, Control KC. Okay. So instead of creating that box, we'll return to the box in a moment. Let's create the following. Let's do model. We're gonna do player dummy equals model create. Okay, and that's it. This just creates the model. If we take a look at the let's see, model, entity model. Oh, too far. Model. So we have the create. As you can see, you can create a cylinder, cone, box, sphere, or you can just create just a new model, empty model. And this just returns a parent, or this can be parented to another object. We don't want to parent to another object. This is going to be our initial object. So if we do this, if we create that model and we run the game, also let's not forget to put in our semicolon because Visual Studio is going to complain now. Okay, we're going to run the project. Okay, as you can see, we don't actually see the model. However, if we copy this, the set physics mode, and we actually set the physics mode of the dummy object now, if we run it now, there's our little the representation, the virtual player dummy, right? It's invisible, but it's still there, and it has a physics body, which is a cylinder. Fantastic. So now if we're gonna re-enable the box, we're gonna create the box 2x2, or well, let's say just size of 2, and we're gonna put a parent, and we're gonna parent it to the player dummy. So now whenever the player dummy moves, this box will move as well. Right? So the box starts at the bottom, and the thing is, when you parent something, it parents to it parents the middle of that object to the dummy object. So the thing is, when you use the function model box, it creates a box, but the center of that box is smack in the center, like right in the middle of the volume of the box, and that is what gets parented to this box. Now, first things first, I want to, just for the sake of visual representation, I want to move the dummy box up so that, you know, we can see it move under gravity. All right, so we're going to do that. We're going to run the project. Okay, and also don't forget, do you see how it's not moving? Once again, you have to set the mass of the object. You don't set the mass, it assumes the mass is 0, it disables the physics on that particular character. So don't forget it. This is gonna drive you nuts. There we go. Okay, so you see the cylinder itself is perfectly colliding with the floor, but the box is falling through because the center of the box is at the foot of the cylinder. So all you have to do is just move the cylinder by just a little bit. And this cylinder, the box, we need to move the box up. And as you can see, the box is now moving relative to its parent, right? Relative to the parent. So basically, I can set the box to be, let's see, left and right. So let's do -7. And this now moves relative to the position of the dummy object. There we go. So now it's moving relative to the dummy object, but it's still attached to it. So whatever the dummy object moves, that's where the character is going to move as well. Okay, fantastic. So how about we attach the camera to this now, eh? Okay, so we got to go player dummy. When we create the camera, we attach the camera there to the player dummy. Fantastic, camera has been attached. All right, nice and simple. Okay, so let's do a little bit of movement, shall we? We're gonna handle the camera movement in just a moment. I just want to do a little bit of some very basic movement. So whenever you have the character physics, you gain an ability okay, so when you set an object to be a character physics object, that object gains a very special method of being controlled, and that method is actually going to be our set input method. Set input. So it's an entity method, so this function is set to movement parameters of an entity that uses the character physics mode. Okay, so the thing is, you can no longer use things like set rotation or set position on these objects. They have to be moved in a bit of a different way. So if you have static objects that don't have any sort of movement, they're just static objects, you can use the set rotation, set position functions. If it's a physics object, it's a little bit different. So set input, you can do angle, which is, left and right camera looking. Movement, so forward and backward, strafe, left and right. Jump, when you clicked on jump, it does a physics calculation when it launches you in the air. Crouch, when it squishes you down. Max acceleration, deceleration. So think of it, maybe maybe you're not controlling a player. Maybe you're controlling a spaceship. Acceleration, deceleration. So instead of just like, instead of moving right away, right? It's going to speed up and, slow down. That's what acceleration and deceleration mean. You don't have to put these things in, right? Max rotation, so this one for moving left and right. For now, let's do angle, movement, strafe, and jump. All right? Angle, movement, strafe, and jump. So we're gonna say the player dummy, because the player dummy is the one that has the player physics. We're gonna do player dummy, and this is already taking place in a while loop, right? Because you gotta movement takes place all the time. So we're gonna do the following. We're gonna say at the angle of 0, player dummy set input 0. Let's do forward movement of 2 and 0 for the strafe and 0 for the jumping. For the time being, we'll handle the keyboard input in just a moment. So we should be able to see. There we go. Characters moving forward at a constant rate. Fantastic. So here's what we're gonna do. Let's create float. What are we gonna do? Forward. Okay, walk. Fine. Forward walk speed. We're gonna get my game window, right? Because it's the game window, the application window that handles keyboard input. So once again, we're just gonna copy this thing because, you know, we don't want to waste everybody's time. My game window key hit. So this is gonna be the W key, and we can actually just let's see. Let's put some logic here. We're going to put it in the brackets. I'm going to do minus my game key. This is for the backwards movement. And we're going to multiply it by 5. Okay, so what's happening here? And of course it deleted all the empty spaces because Visual Studio loves us like that. Okay, so walk speed. We're actually, you know, let's define walk speed in the beginning so we don't have to redefine it every single loop. So we're going to say walk will be equals to, if you're holding down the W key, this whole thing returns a 1. So it's 1 times 5. Okay? If you're holding the S key, it's basically, and you're not holding down the W key, this returns 0 minus 1. So this whole thing gets a minus 1 times 5, which is minus 5. So suddenly, when you're holding W, you get plus 5. When you're holding S, you get minus 5. If you're holding them both, well, you cancel each other out, so there's no movement at all. Okay? Okay, and of course, I forgot to take this variable and shove it in here. Fantastic. Okay. Forward, backward. Okay. Do you see how we're using keyboard hit? Keyboard hit only works when we hit the key, not when we hold down. So we're going to use key down instead. Run that. And now we can actually move back and forth, right? Now you can see we have acceleration and deceleration, so, or acceleration. Acceleration? I don't know. So we have moving back and forth. Okay, let's duplicate this. Control D on the whole line. Strafe. I'm going to shove strafe right in here. And now in here, we're going to use, let's see. So strafe actually needs to also be defined. Otherwise, it complains that the variable doesn't exist and we're trying to set it before we create it. So this is going to be left and right movements. So this will be D positive for A negative times 5. Okay. Okay, here we go. We have our back and forth movement. Fantastic. Right? Now, the next thing is jumping. We're going to create a variable called jump. Jump will be equals to, and this time we can actually use the hit instead of down. Because if it's hit, then for as long as we're holding down the key, we're going to be flying upwards. All right, so we're going to put in the jump right over here. Oh, and this is not supposed to be the D key, this is supposed to be the space key. And it's already compiling the game, so I need to close it in just a moment. Okay, here we go. Run the game. Okay, so you can see that it's very tiny because, you know, this returns a 1 if you hit the key. Effectively, our jump is equals to 1. If we set it to 10, it's going to be 10 times as powerful. Okay. And there's our jumping. Fantastic. And it looks like we already have the physics body where you can slightly change the direction of your jump in mid, which is, you know, classical FPS stuff. Fantastic. And look at that. Shadows, lighting, already in. Don't have to bother with coding the shaders to do that. Fantastic. Now, if we actually do this as down, once again, you don't have to make this a first-person character game. This can be a spaceship, right? You can be floating through the space of the nether. And this is basically, this is what it is, right? Hold down space, floating in, there's gravity, like that, right? Floating around. Fantastic. All right. Okay, perfect. So let's do this. Let's actually get our character, the box. Let's move it. Let's move the box in the center of the center of our dummy. So if we create a box that is the size of 2, which is 2 by 2 by 2, then all we have to do, if the middle of it gets stuck in the ground, we just have to move it up by 1. Okay, so if we move it up by 1, the box should appear as if it's perfectly stationed on the ground, or yeah, perfectly colliding with the ground. As you can see, there we go. All right, now we do have a little bit of clipping, and we would just have to adjust the player collision box, or collision cylinder. All right, we'll do that afterwards. Fantastic. So now that we have this in place, let's actually move the camera a little bit closer as well. Let's do, so 5, but let's do -4, and let's do 3 for the offset. This is already, like, we're basically making a third-person game right now. If you want a first-person game, don't create the box that represents your player and position the camera exactly where you position the dummy object. We'll handle that next time. All right. Technically, from this alone, you should already be able to do that. Fantastic. So now that we have our character movement back, forth, left, and right, let's get the camera positioning. Now, if you remember, during the horror game genre boom of 20 whatnot, when Unity horror games became, like, they were being pumped out like rabbits, there was a constant problem of when you're playing a game in full screen, or in windowed mode, your mouse was free to move around. And what happened is that when you click outside of the window, it would close the game. And usually this would happen when you're running around, running away from some slender creature. And that's basically causing a lot of grief for a lot of people. And that's why, Unity has been getting that stigma attached to it at that particular period of time, where it's like, oh, I can click outside the window. It must mean that this game was made in Unity. I'm pretty sure at that point Unity did offer the proper functions to handle this. It's just people did not know what it was or how to use it. That's why this was such an issue. So how do we actually get mouse input? Well, once again, we have to use the window that we created. So my game window, get mouse position. Now here's the thing. Get mouse position returns a vector3 value, which means it's a little box that contains 3 values in it. So that's why in order for us to actually use it, we need to create a vector3 value, which is going to be mouse data. And, let's just declare it. And can we just declare it? Oh, vector3 has to start with a capital letter. Beautiful. So we declare the variable. We don't have to set it to anything. If you want to set it to anything, you can just do vector3 and then you do 0, 0, 0. Because once again, this piece of data contains 3 pieces of information. So you have to set it to the same type of data that the value is in. Same thing we were talking about over here, right? If you want to store this sort of data, the variable has to match in its type. If you want to store this sort of data, the variable has to match in its type. Okay? I'm like beating a dead horse, I think, by this point. So, fantastic. We have our mouse data. All we have to do is say mouse data equals my game window, get the position of the mouse, and now we're basically we have the mouse data in this case. Okay, so how do we actually access the mouse data? Well, mouse data, and we treat it like an array. So we basically do this, and this gets us the very first value, this value, right? Or in this case, because we've already taken the mouse data, this will be equals to the X position of the mouse. If we use 1, that's this one. This is the Y position of the mouse, and 2 is this one, which is the scroll wheel, the position of the scroll wheel. So you can use that for controlling something in your game. Okay, so if we take this, so X position, right? We take the X position, we shove it into here. When we take the input, you will see that the mouse X, or this is actually the Y position, apologies, this has to be 0. 0 is the X position. So you'll see that we can move the object around. We move the dummy object, and the camera is attached to the dummy object, so the camera moves as well. So as you can see, the mouse moves with our object, but there's a bit of a problem. First of all, it's way too fast, which you could technically do this multiplied by 0.1, but that's not the biggest issue in this whole control scheme. The biggest issue is that our mouse, right? So as you can see, we can move around seemingly okay, but do you see how our mouse can move freely in the window? And once again, it can leave the game window, and if you accidentally click anywhere else, you leave the game. That's not a good thing. So first things first, we cannot use, or we should not use, the absolute position of the mouse in the screen. That's not how, this is, you know, as you saw, this is going to cause issues. What we have to do, first of all, we have to make sure that the mouse cannot leave the screen, cannot leave the game, so it doesn't cause any problems. So what we have to do, I'm going to just get rid of this for the time being. Okay, and I'm going to snap the mouse to the middle of the screen, just like that. So my game window, set mouse position, my game window, get the width of our window, right? So our window was 1280 by 720. This is the width. So half of this width, we get the width of the window divided by 2, so halfway. Same thing for the height. My game window, get height, halfway through the height. So now, if we run the game, you'll see that the mouse is stuck to the middle of the screen. And there we go. Now you see how there's still a little bit of movement in the mouse. And this is good, because this tiny movement is what we can actually still read and use in order to move our camera around, or move our dummy object, which rotates the camera around with it. All right, so how do we actually do that? We need to declare two float variables, mouse X and mouse Y. And before we set the mouse to be in the center, we need to basically calculate the not calculate, but we need to calculate what is the distance of the mouse from that center point when we move the mouse before we snap it back to the center, right? So how do we do this? We do mouse X. We add to this value the mouse data, and this is the X coordinate, so that's the first value, this value right here. Okay, we do mouse data, then we once again need to go, whoops, excuse me, copy the wrong thing, my game window, get width divided by 2. Okay, so what does this actually do? We basically we technically, for the time being, we don't need these brackets. This will come later in just a moment. So let's see. This actually has to be a minus, not a comma. That's what kind of threw me off. Okay, so we take the middle along the width, the middle of the screen, and we take the current position of the mouse, and we basically calculate the difference between the current position of the mouse and the middle of the screen. And this will give us how far is the mouse away from the middle of the screen along the x-axis, right? If we take mouse X and shove it in here now, you will see that that incremental movement before we snap the mouse back to the center of the screen is going to effectively control our character. Now you see it's a little bit too intensive, so that's why I originally had the brackets in here, and we can just multiply the resulting value by 0.1, and this will basically use 1/10 of the total value of this of whatever the difference is. Okay, so as you can see, this is a little bit more plausible. All right, fantastic. And you see I can still fly around. Okay, that looks good. Let's do the same thing for the y, and then this time we're gonna use the y coordinate of the mouse. We're gonna get the height, apparently, the height, and we'll divide it by 2. Now, when it comes to up and down movement, we can actually move the camera up and down. So this is where you're going to have to experiment a little bit with how you want to handle your camera. For the sake of just experimentation, we can just go ahead and say that after we move the player dummy, we're going to do the my player camera set rotation. And with the set rotation, we want to do, I think, 0, and then mouse Y, and then 0. Okay. All right. So this will rotate the camera. Now here's something you need to okay. All right. So as you can see, that rotates the camera, but it doesn't quite rotate it in the way we need it. So this should actually be, I believe, right over here. That looked kind of weird. Okay. Hey, fantastic. So the thing is, it moves our camera along the camera axis as opposed to the little cube axis. So what if we do want to move what if we want to move the camera up and down around the object that it's pointing at, not, you know, moving the actual camera up and down, so the object is remaining right here, but the camera is looking up like that, right? We want to move the camera around the object that we're looking at, right? Instead of like this, right? Ooh, vertigo. Although, you know, once again, depending on what kind of game you're making, this could be done in this way as well. We're going to close this. We're going to go up here where we pair the camera to the dummy. And instead of pairing the camera to the dummy, we can pair the camera to the player box. All right, player box. So now, instead of rotating the camera, we can rotate the player box. And you can do all kinds of finicky stuff, like funky stuff, with pairing of objects to one another, and their offsets are getting altered. All kinds of cool stuff. All right, now this part I'm actually improvising. This is not in my notes. And if it doesn't work, then I look like an ass. Hey, look at that. Perfect. So you see now you're rotating the box, and since the camera is now paired to the box, it keeps the actual character always in sight. You can technically rotate the camera right now. Maybe something like, oh, this is the camera right here. So we're going to rotate the camera by, let's do what, like 15 degrees? And whether or not that's in degrees, I have yet to verify. Oh, I just realized that I'm actually not rotating the appropriate entity. I have to be rotating the camera. I want to keep that box in sight, basically. There we go. Okay, so now the box is in sight. Fantastic. Now, what if we don't want to rotate the actual object? Well, once again, let's just go about... let's create another empty model. Model, camera, camera, mount equals model, create. Okay, we're going to attach the camera mount model, which is once again an invisible entity. We're going to attach it to the player dummy, and then when we create the camera, the camera gets attached to the camera mount. And now when we rotate, what we rotate is going to be the camera mount instead of the actual player box. All right, let's run this. And you can experiment with all kinds of camera angles, positioning, you know, position smack in the middle. Maybe you want to position it a little bit to the right. And as you can see now, the box is stationary. However, the camera is moving up and down. You're going to want to figure out things like collisions with the floor. For example, if you're detecting a collision of, maybe you want to attach another box with like a sphere to the camera, and you say if the camera is colliding with the floor, don't let it go anywhere further than this. We're going to cover that in the next video. Okay, fantastic. So I think that this pretty much sets you up for the basics. You can now start playing around, you know, go back to the Leadwerks engine, you know, maybe play some other stuff, and play around with some additional features. You know, you can position this thing over here, go back to Visual Studio, run the project. Oh yeah, and don't forget to save the actual map, otherwise it's not going to push the changes to it. Okay, and there's our box. Fantastic. So super simple, nothing complicated. You can already start playing around with all kinds of stuff. As I said, this is why I really like this engine. This engine really appeals to me. The ease of creating this stuff in code while, you know, having the lighting, the shadows, very competent visual presentation, very strong set of tools, fantastic stuff. So this is going to be your introduction video. The rest of the videos are going to go on the Concept Bay platform, so you can pick those up and find all kinds of additional things you can do in order to create your games, okay? I'm really excited to play around with this some more. So, yeah, I will see you guys in the next video. Thanks for watching. Make sure to check out the Concept Bay platform. You'll find a lot of educational content there. It's currently, like, I'm going to say this, well, I'm saying this now, but I'm currently still building the platform, so this is just kind of future-proofing the video. Like, oh yeah, there's like millions of videos you can find on how to make video games. Right now, there's like 2 or 3 videos on there. So future-proofing for now. You can sign up for the Concept Bay platform as of right now. The platform is currently under construction. There may be bugs. If you guys can check it out, and if you find any bugs, you can let me know. I'll fix them up, and we'll get the process up and running. Okay, so thank you so much for watching, and I'll see you guys in